Cobol is a compiled computer programming language designed for business use. It is imperative, procedural and, since 2002, object-oriented. It was designed in 1959 by the Conference on Data Systems Languages and was largely based on previous programming language design work by Grace Hopper, commonly referred to as the mother of COBOL. COBOL stands for Common Business-Oriented Language. COBOL is primarily used in business, finance, and administrative systems for companies and governments. In 1997, Gartner Group estimated that there were a total of 200 billion lines of COBOL in existence, which ran 80% of all business programs. COBOL was one of the first programming languages to be standardized. The first COBOL standard was issued by ANSI in 1968. The standard has been revised 4 times since then, with ISO publishing the latest standard as ISO IEC 1989-2014. History and specification. Background: computer users and manufacturers were becoming concerned about the rising cost of programming. A 1959 survey had found that in any data processing installation, programming cost at least $800,000 and that translating programs to run on new hardware would cost $600,000. In a time where new programming languages were proliferating at an ever-increasing rate, the same survey suggested that if a common business-oriented language were used, conversion would be far cheaper and faster. In 1959, Grace Hopper, inventor of the English-like data processing language Flow MATIC, led a group of users and manufacturers to ask the Department of Defense to sponsor an effort to create a common, problem-oriented, hardware-independent programming language. The delegation impressed Charles A. Phillips, director of the Data System Research staff at the DoD, who thought that they thoroughly understood the DoD's problems. The DoD operated 225 computers, had a further 175 on order and had spent over $200 million on implementing programs to run on them. Portable programs would save time, reduce costs and ease modernization. Phillips agreed to sponsor the meeting and tasked the delegation with drafting the agenda. Cobol 60. On May 28 and 29 of 1959, a meeting was held at the Pentagon to discuss creating a common programming language for business. It was attended by 41 people and was chaired by Phillips. The Department of Defense was concerned about whether it could run the same data processing programs on different computers. Fortran, the only mainstream language at the time, lacked the features needed to write such programs. Representatives enthusiastically described a language which could work in a wide variety of environments, from banking and insurance to utilities and inventory control. They agreed unanimously that more people should be able to program and that the new language should not be restricted by the limitations of contemporary technology. A majority agreed that the language should make maximum use of English, be capable of change, be machine independent and be easy to use, even at the expense of power. The meeting resulted in the creation of CODASYL and 3 committees, short, intermediate and long range. The short range committee was given to September to produce specifications for an interim language. Their official mission, however, was to identify the strengths and weaknesses of existing programming languages and did not explicitly direct them to create a new language. The deadline was met with disbelief by the short range committee. One member, Betty Holberton, described the 3-month deadline as gross optimism, and doubted that the language really would be a stopgap. The short-range committee was made up of members representing 6 computer manufacturers and 3 government agencies. The 6 computer manufacturers were Burroughs Corporation, IBM, Minneapolis Honeywell, RCA, Sperry Rand, and Sylvania Electric Products. The 3 government agencies were the U.S. Air Force, the Navy's David Taylor Model Basin, and the National Bureau of Standards. The committee was chaired by Joseph Wegstein of the U.S. National Bureau of Standards. It soon became apparent that the committee was too large for any progress to be made quickly. A frustrated Howard Bromberg bought a $15 tombstone with COBOL engraved on it and sent it to Charles Phillips to demonstrate his displeasure. A subcommittee was formed to analyze existing languages and was made up of 6 individuals, William Selden and Gertrude Tierney of IBM, Howard Bromberg and Howard Discount of RCA, Vernon Reeves and Jeannie Sammet of Sylvania Electric Products. The subcommittee did most of the work creating the specification, leaving the short-range committee to review and modify their work before producing the finished specification. The committee mainly investigated the Flowmatic, IMACO and Comtran programming languages. The Flowmatic language was particularly influential because it had been implemented and because IMACO was a derivative of it with only minor changes. Flowmatic's inventor, Grace Hopper, served as a technical advisor to the committee. IBM's Comtran language invented by Bob Beamer was also drawn upon, but it was regarded as a competitor to Flowmatic by a short-range committee made up of colleagues of Grace Hopper. Some of its features were not incorporated into Cobol so that it would not look like IBM had dominated the design process. When Roy Goldfinger, author of the Comtran Manual and Intermediate Range Committee member, attended a subcommittee meeting to support his language and encourage the use of algebraic expressions, Grace Hopper sent a memo to the Short Range Committee reiterating Sperry Rand's efforts to create a language based on English. In 1980, Grace Hopper commented that Cobol 60 is 95% Flowmatic, and that Comtran had had an extremely small influence. Furthermore, she said that she would claim the work was influenced by both Flowmatic and Comtran only to keep other people happy, so they wouldn't try to knock us out. Features from Comtran incorporated into Cobol included an improved if statement which obviated the need for GOTOs and a more robust file management system. The specifications were presented to the Executive Committee on September 4. They fell short of expectations. Joseph Wegstein noted that it contains rough spots and requires some additions, and Bob Beamer later described them as a hodgepodge and gave the subcommittee until December to improve it. In October, the Intermediate Range Committee received copies of the FACT language specification created by Roy Nutt. Its features impressed the committee so much that they passed a resolution to base Cobol on it. This was a blow to the Short Range Committee, who had made good progress on the specification. Despite being technically superior, FACT had not been created with portability in mind or through manufacturer and user consensus. It also lacked a demonstrable implementation, allowing supporters of a Flowmatic-based Cobol to overturn the resolution. RCA representative Howard Bromberg also decided to block FACT so that RCA's work on a Cobol implementation would not go to waste. The name Cobol was coined by Bob Beamer. The subcommittee completed the specifications for Cobol in December 1959. The specifications approved by the Short Range Committee were approved by the Executive Committee on January 3, 1960, and sent to the Government Printing Office, which printed these as Cobol 60. The language's stated objectives were to allow efficient, portable programs to be easily written, to allow users to move to new systems with minimal effort and cost, and to be suitable for inexperienced programmers. The CODASYL Executive Committee later created the Cobol Maintenance Committee to answer questions from users and vendors and to improve and expand the specifications. During 1960, RCA and Sperry Rand worked on creating a Cobol compiler. The first Cobol program was run on August 17 on an RCA 501. On December 6 and 7, the same Cobol program ran on an RCA computer and a Remington Rand Univ computer, demonstrating that compatibility could be achieved. Cobol 61 to Cobol 65. Cobol 60 was replaced in 1961 by Cobol 61. This was then replaced by the Cobol 61 extended specifications in 1963, which introduced the sort and report writer facilities. The added facilities fixed flaws identified by Honeywell in late 1959 in a letter to the Short Range Committee. Cobol, edition 1965 brought further clarifications to the specifications and introduced facilities for handling mass storage files and tables. Cobol 1968. Efforts began to standardize Cobol to overcome incompatibilities between versions. In late 1962, both ISO and the United States of America Standards Institute formed groups to create standards. ANSI produced USA Standard COBOL X 3.23 in August 1968, which became the cornerstone for further versions. This version was known as American National Standard COBOL, COBOL 1974. By 1970, COBOL had become the most widely used programming language in the world. Independently of the ANSI committee, the CODASYL Programming Language Committee was working on improving the language. They described new versions in 1968, 1969, 1970 and 1973, including changes such as new inter-program communication, debugging and file merging facilities, as well as improved string handling and library inclusion features. Although CODASYL was independent of the ANSI committee, the CODASYL Journal of Development was used by ANSI to identify features which were popular enough to warrant implementing. The Programming Language Committee also liaised with ECMA and the Japanese COBOL Standard Committee. In 1974, ANSI published a revised version of COBOL, containing new features such as file organizations, the delete statement and the segmentation module. Deleted features included the note statement, the examine statement and the implementer-defined random access module. These made up 44 changes which rendered existing statements incompatible with a new standard. The report writer was slated to be removed from COBOL, but was reinstated before the standard was published. COBOL 1985. In June 1978, work began on revising COBOL 74. The proposed standard differed significantly from the previous one, causing concerns about incompatibility and conversion costs. In January 1981, Joseph T. Brophy, Senior Vice President of Travelers Insurance, threatened to sue the Standard Committee because it was not upwards compatible with COBOL 74. Mr. Brophy described previous conversions of their 40 million line code base as non-productive, and a complete waste of our programmer resources. Later that year, the Data Processing Management Association said it was strongly opposed to the new standard, citing prohibitive conversion costs and enhancements that were forced on the user. During the first public review period, the committee received 2,200 responses, of which 1,700 were negative form letters. Other responses were detailed analyses of the effect COBOL 80 would have on their systems. Conversion costs were predicted to be at least 50 cents per line of code. Fewer than a dozen of the responses were in favor of the proposed standard. In 1983, the DPMA withdrew its opposition to the standard, citing the responsiveness of the committee to public concerns. In the same year, a National Bureau of Standards study concluded that the proposed standard would present few problems. A year later, a COBOL 80 compiler was released to DEC-VAX users, who noted that conversion of COBOL 74 programs posed few problems. The new evaluate statement and inline perform were particularly well received and improved productivity, thanks to simplified control flow and debugging. The second public review drew another 1,000 responses, while the last drew just 25, by which time many concerns had been addressed. In late 1985, ANSI published the revised standard. 60 features were changed or deprecated and many were added, such as scope terminators, nested subprograms, the continue statement, the evaluate statement, the initialize statement, inline perform body, reference modification, I/O status codes. Two amendments followed in 1989 and 1993, the first introducing intrinsic functions and the other providing corrections. The 1985 standard and its amendments were adopted by ISO, who subsequently took primary ownership and development of the standard. COBOL 2002 and object-oriented COBOL. In the early 1990s it was decided to add object orientation in the next full revision of COBOL. Object-oriented features were taken from C++ and Smalltalk. The initial estimate was to have this revision completed by 1997 and an ISO committee draft was available by 1997. Some vendors introduced object-oriented syntax based on drafts of the full revision. The final approved ISO standard was approved and made available in 2002. Fujitsu Software, Micro Focus and Raincode introduced object-oriented COBOL compilers targeting the .NET framework. There were many other new features, many of which have been in the CODASYL Cobol Journal of Development since 1978 and had missed the opportunity to be included in Cobol 85. These other features included free-form code, user-defined functions, recursion, locale-based processing, support for extended character sets such as Unicode, floating-point and binary data types, portable arithmetic results, bit and Boolean data types, pointers and syntax for getting and freeing storage, the screen section for text-based user interfaces, the validate facility, improved interoperability with other programming languages and framework environments such as .NET and Java. 3 core agenda were published for the standard, 2 in 2006 and 1 in 2009. There are 3 technical reports which describe object finalization, XML processing and collection classes for Cobol. Cobol 2014. Cobol 2014 includes the following changes: portable arithmetic results have been replaced by IEEE 754 data types, major features have been made optional, such as object orientation, the validate facility, the report writer and the screen handling facility. Method overloading, dynamic capacity tables, legacy. Cobol programs are used globally in governments and businesses, and are running on diverse operating systems such as ZOS, VME, Unix and Windows. In 1997, the Gartner Group reported that 80% of the world's business ran on Cobol, with over 200 billion lines of code and 5 billion lines more being written annually. Near the end of the 20th century, the year 2000 problem was the focus of significant Cobol programming effort, sometimes by the same programmers who had designed the systems decades before. The particular level of effort required to fix Cobol code has been attributed to the large amount of business-oriented Cobol, as business applications use dates heavily, and to fixed-length data fields. After the cleanup effort puts into these programs for Y2K, a 2003 survey found that many remained in use. The authors said that the survey data suggest a gradual decline in the importance of Cobol in application development over the following 10 years unless integration with other languages and technologies can be adopted. In 2006 and 2012, Computer World surveys found that over 60% of organizations used Cobol and that for half of those, Cobol was used for the majority of their internal software. 36% of managers said they plan to migrate from Cobol and 25% said they would like to if it was cheaper. Instead, some businesses have migrated their systems from expensive mainframes to cheaper, more modern systems, while maintaining their Cobol programs. Features, syntax. Cobol has an English-like syntax which is used to describe nearly everything in a program. For example, a condition can be expressed as AX is greater than Y or more concisely as AX greater Y or AX, Y. More complex conditions can be abbreviated by removing repeated conditions and variables. For example, AA, B and A, C or A equals DAR can be shortened to A, B and C or equals D. As a consequence of this English-like syntax, Cobol has over 300 keywords. However, compiler extensions mean many implementations have far more. One implementation recognizes over 1,100 keywords. A Cobol program is split into 4 divisions: the identification division, the environment division, the data division and the procedure division. The environment division specifies any program features that depend on the system running it, such as files and character sets. The data division is used to declare variables and parameters. The procedure division contains the program's statements. Each division is subdivided into sections which are made up of paragraphs. Within these are sentences made up of statements. Statements are made up of clauses and further statements. Statements containing statements may be terminated in 2 ways, by a period, which terminates all unterminated statements contained, or by a scope terminator, which terminates the nearest matching open statement. Nested statements terminated with a period are a common source of bugs. For example, examine the following code. Here, the intent is to display Y and Z if condition X is true. However, Z will be displayed whatever the value of X because the if statement is terminated by an erroneous period after a display Y. Another bug is a result of the dangling else problem, when two if statements can associate with an else. In the above fragment, the else associates with the if YA statement instead of the if ZA statement, causing a bug. Prior to the introduction of explicit scope terminators, preventing it would require an else next sentence to be placed after the inner if. Code format. Fixed format code is the default code format. Up to Cobol 85, fixed format code was split into 5 areas. In Cobol 2002, free format code was introduced. It allowed code to be placed in any column of the file, like newer languages such as C and Pascal. The comment indicator was replaced by which could be placed anywhere and be used in fixed format source code. The slash indicator was replaced with the new compiler directive and words cannot be continued. Fixed format code remains the default format, however, and the only changes to it in Cobol 2002 were that areas A and B were merged and their size left to the implementer. Aggregated data. Data items in Cobol are declared hierarchically through the use of level numbers which indicate if a data item is part of another. An item with a higher level number is subordinate to an item with a lower one. Data items which are not subordinate to another item are called records. Items that have no subordinate data items are called elementary items. Those that do are called group items. In the above example, num and the date are subordinate to the record some record while the year, the month and the day are part of the group item the date. Level numbers used to describe standard data items are between 1 and 49. A level number of 66 is used to declare a regrouping of previously defined items, irrespective of how those items are structured. 77 indicates the item is standalone and in such situations, is equivalent to the level number 1. 88 declares condition names which are true when the parent data item contains one of the values specified in the condition. Data types. Standard Cobol provides the following data types: numeric. Numeric data can be stored in several formats: binary, where a minimum size is either specified by the picture clause or by a usage clause such as binary long. Usage computational, where data may be stored in whatever format the implementation provides. Often equivalent to a usage binary. Usage display, the default format, where data is stored as a string, floating point, in either an implementation-dependent format or according to IEEE 754. Usage national, where data is stored as a string using an extended character set. Usage packed decimal, where data is stored in the smallest possible decimal format. Edited data are formatted string types that are specified by a picture clause. For example, a 9 indicates that there will be a numeric character at a position and a indicates that there will be a comma character at that position unless the character after it is a space, in which case it will also be a space. There are 3 types of edited data: alphanumeric edited, national edited and numeric edited. Numeric edited data can be represented using either the normal character set or the national set. Extensions. Most vendors provide additional types, equivalents of which are now in the standard. These extensions include files. Cobol supports 3 file formats, or organizations: sequential, indexed and relative. In sequential files, records are contiguous and must be traversed sequentially, similarly to a linked list. Indexed files have one or more indexes which allow records to be randomly accessed and which can be sorted on them. Each record must have a unique key, but alternate record keys need not be unique. Implementations of indexed files vary between vendors, although common implementations, such as CISAM and BSAM, are based on IBM's ISAM. Relative files, like indexed files, have a unique record key, but they do not have alternate keys. A relative records key is its ordinal position. For example, the 10th record has a key of 10. This means that creating a record with a key of 5 may require the creation of preceding records. Relative files also allow for both sequential and random access. A common non-standard extension is the line sequential organization, used to process text files. Records in a file are terminated by a new line and may be of varying length. Procedures. The sections and paragraphs in the procedure division can be used as labels and simple subroutines. Unlike in other divisions, paragraphs do not need to be in sections. Execution goes down through the procedures of a program until it is terminated. Procedures can be used with a perform statement which acts like a GOSUB in BASIC. Performing a section means that execution travels through any paragraphs it contains, even if doing so will take control flow out of the specified procedures. In COBOL 74, subprograms were added, allowing the separation and encapsulation of different parts of the program. Subprograms can be called either statically or dynamically. Static calls are known at compile time, but dynamic calls are evaluated at runtime based on a string or pointer variable. Intrinsic functions were added to COBOL in the 1989 addendum to COBOL 85. The addendum added various common mathematical, string and date functions including sin, uppercase and current date. Functions may be preceded by the word function and those with no parameters may be used with or without parentheses. In 2002, user-defined functions were added. Self-modifying code. The original COBOL specification supported the infamous alter X to precede TOER statement, for which many compilers generated self-modifying code. X and Y are paragraph labels, and any GOTOER statements executed after such an alter statement mean a GOTOER instead. Many compilers still support it, but it was deemed obsolete in the COBOL 1985 standard and should not be used in new programs. The use of alter has been banned altogether for some time by many software companies as part of their programming practices. Object-oriented programming, classes and interfaces were added in COBOL 2002. Classes have factory objects, containing class methods and variables, and instance objects, containing instance methods and variables. Inheritance and interfaces provide polymorphism. Support for generic programming is provided through parameterized classes, which can be instantiated to use any class or interface. Objects are stored as references which may be restricted to a certain type. There are two ways of called a method, the invoke statement, which acts similarly to call, or through inline method invocation, which is analogous to using functions. COBOL does not provide a way to hide methods. Class data can be hidden, however, by declaring it without a property clause, which leaves the user with no way to access it. Method overloading was added in COBOL 2014. Hello, World, a Hello, World program in COBOL. Criticism and defense, lack of structure. In his letter to an editor in 1975 entitled, How Do We Tell Truths That Might Hurt?, which was critical of several of COBOL's contemporaries, computer scientist and Turing Award recipient EDSG Dijkstra remarked that the use of COBOL cripples the mind. Its teaching should, therefore, be regarded as a criminal offense. In his dissenting response to Dijkstra's article and the above offensive statement, computer scientist Howard E. Tompkins defended structured COBOL. COBOL programs with convoluted control flow indeed tend to cripple the mind, but this was because there are too many such business application programs written by programmers that have never had the benefit of structured COBOL taught well. COBOL lacked any facility for defining independent subprograms until COBOL 74. This complicated development because it meant that all variables were global and could be modified anywhere within the program. However, its varied control structures reduced the need for GOTOs. The perform statement, for example, allowed programmers to easily access powerful looping facilities. Additionally, the introduction of ʻkoʊbʒl has added support for object-oriented programming as well as user-defined functions and user-defined data types to COBOL's repertoire. Compatibility issues. After standardization, COBOL 85 was not fully compatible with earlier versions, resulting in the caesarean birth of COBOL 85. Joseph T. Brophy, the CIO of Travelers Insurance, spearheaded an effort to inform users of COBOL of the heavy reprogramming costs of implementing the new standard. As a result, the ANSI COBOL committee received more than 2,200 letters from the public, mostly negative. requiring the committee to make changes. On the other hand, conversion to COBOL 85 was thought to increase productivity in future years, thus justifying the conversion costs. Verbose syntax. COBOL syntax has often been criticized for its verbosity. However, proponents note that this was intentional in the language design because it made the code self-documenting, easing program maintenance. COBOL was intended to be easier for programmers to learn and use, but while being readable to non-technical staff such as managers. The desire for readability and good program documentation is why COBOL has English-like syntax and structural elements, such as nouns, verbs, clauses, sentences, sections, and divisions. Consequently, COBOL is considered by one source to be the most readable, understandable and self-documenting programming language in use today. Not only does this readability generally assist the maintenance process, but the older a program gets, the more valuable this readability becomes. On the other hand, by 1984, maintainers of COBOL programs were struggling to deal with incomprehensible code, and the main changes in COBOL 85 were there to help ease maintenance. Gene Summit, a short-range committee member, noted that little attempt was made to cater to the professional programmer. In fact, people whose main interest in programming tend to be very unhappy with COBOL, which he attributed to COBOL's verbose syntax. Alienation from the computer science community. The COBOL community has always been isolated from the computer science community. No academic computer scientists participated in the design of COBOL. All of those on the committee from commerce or government. This was due to the differing interests of computer scientists at the time, who were more interested in fields like numerical analysis, physics and system programming than the commercial file processing problems which COBOL development tackled. The COBOL specification did not use the new Bacchus-Naur form to describe the language's syntax, resulting in severe criticism at the time. Later, COBOL suffered from a shortage of material covering it. It took until 1963 for introductory books to appear. By 1985, there were twice as many books on Fortran and 4 times as many on BASIC than on COBOL in the Library of Congress. As COBOL became a mainstream language, COBOL suffered as university professors taught more modern, state-of-the-art languages and techniques instead of COBOL, which was said to have a trade school nature. Donald Nelson, the chair of the CODASYL COBOL Committee, said in 1984 that academics hate COBOL, and that computer science graduates had hate COBOL drilled into them. Flawed language features. COBOL suffered from poor string handling facilities, which were only fixed in COBOL 74. The hard-to-spot and easily mislaid scope delimiting period was superseded in COBOL 85 by scope terminators, 25 years after the Bediner-N delimiters were introduced in ALGOL. Until COBOL 85, only paragraphs could be used in perform statements, which made programs harder to understand as the reader had to search for the body of the statement. Functions were introduced in the 1989 amendments, and user-defined functions were only introduced in COBOL 2002. Designed by committee, there were doubts about the effectiveness of the design process. Short-term committee member Howard Bromberg said that there was little control over the development process and that it was plagued by discontinuity of personnel and a lack of talent. COBOL standards have repeatedly suffered from delays. COBOL 85 arrived 5 years later than hoped, COBOL 2002 was 5 years late, and COBOL 2014 was 6 years late. To combat delays, the Standard Committee allowed the creation of optional addenda which would add features more quickly than by waiting for the next standard revision. However, some committee members raised concerns about incompatibilities between implementations and frequent modifications of the standard. Other defenses. COBOL's data structures influenced subsequent programming languages. Its record and file structure influenced PLI and Pascal, and the redefines clause was a predecessor to Pascal's variant records. Explicit file structure definitions preceded the development of database management systems, and aggregated data was a significant advance over Fortran's arrays. COBOL included primitive capabilities for a library system in 1959 through the include statement, the same year that Jovial introduced the communication pool concept. which allowed programs to share data by providing a centralized data description. Despite Gene Summit describing these capabilities as inadequate in retrospect, the copy facility became a successful feature that influenced the development of include directives. Until Cobol 2002, Cobol was a simple language with a limited scope of function, encouraging a straightforward coding style. This has made it well suited to its primary domain of business computing, where the program complexity lies in the business rules that need to be encoded rather than sophisticated algorithms or data structures. Standardization meant programs written in Cobol are portable, and language has since spread onto a wide variety of hardware platforms and operating systems. Additionally, the rigid hierarchical structure restricts the definition of external references to the environment division, which simplifies platform changes in particular. See also, Programming language genealogies, alphabetical list of programming languages, comparison of programming languages, CODASYL, references. External links, Cobol Standards Committee website.